Hello learners, here Mr. G, and it's been a couple of days I couldn't post any video. I'm sorry about that. The thing is I've been battling with internet issues. Okay, but here we are. We are going to be doing today the principle of conservation of mechanical energy. This topic in grade 10 is going to be done later on, but in grade 12 you need it now. You need it now for the work you are doing. So let's first of all recall what the principle of conservation of mechanical energy state. Now, this principle states that the total mechanical energy, where total is important, total mechanical energy in an isolated system remains constant. So what does it mean? It means that mechanical energy do not change. So change of mechanical energy is equal to zero because it does not change. So if you fix this one, remember change is final mechanical energy minus initial mechanical energy. That is change, and that is equal to 0. If you rearrange this one, you have that the mechanical energy, sorry for the M, is not M, is EM. Mechanical energy initial is going to be equal to mechanical energy final. That is, in other words, the law. Remember, this is happening in an isolated system. This is happen in an isolated system. It's not any system. Okay? Now, if the system is not isolated, then energy is conserved, but not mechanical energy. Remember also that energy is always conserved. But we are not talking about energy, we are talking about mechanical energy. And mechanical energy is only conserved if the system is isolated. So if we carry on here a little bit more, remember in grade 10 you learned that mechanical energy is equal to the sum of potential energy plus kinetic energy. That is mechanical energy, and obvious, it must be substituted in the final mechanical energy as well as in the initial mechanical energy. So what we have here now, initial, what do we have initial? The initial potential energy plus the initial kinetic energy, that is initial mechanical energy, equal to what is final mechanical energy? Final potential energy plus final kinetic energy, and this is the final mechanical energy. And further on, also in grade 10 you learned that kinetic energy is equal to half the product of mass multiplied by the speed to the power 2, and you learned that the gravitational potential energy is equal to the product of mass acceleration due to gravity multiplied by the height. This is important, and this could be substituted now in this specific expression there for initial and final. So let's do so, and that will be the end of this explanation of the law. So here we have the initial potential energy is the mass multiplied by the acceleration due to gravity multiplied by the initial height plus half the mass of the object multiplied by the initial speed of the object to the power 2, and this is equal to mass multiplied by acceleration due to gravity multiplied by height final plus half mass multiplied by the final speed to the power 2. This is, in other words, the principle of conservation of mechanical energy. You can use any of those expressions. Okay, so let's now look at one example. Let's look at one example. This example says during a flood, a tree trunk of mass 100 kg falls down a waterfall. The waterfall is 5 meters high. If the air resistance is ignored, important here, the air resistance is ignored. It doesn't mean that there is no air. It means that we are going to ignore that. That means that the system is isolated. The system is isolated. So they said calculate the magnitude of the velocity of the tree trunk at the bottom of the waterfall. So during a flood, a tree trunk of mass 100 kg, there is the mass, falls down a waterfall. The waterfall is 5 meters height. So that is the data, and we are going to use the law or the principle of conservation of mechanical energy. We can straightforward say that the mass multiplied by acceleration due to gravity multiplied by the initial height plus half mass multiplied by the initial speed square is equal to a mass acceleration due to gravity final height plus half mass final speed square, and that is what you are looking for, the velocity at the bottom of the tank. Now here important, you can actually use sometimes projectile, but this is not the purpose here. We're going to use the conservation of energy. So all we have to do, this is the law, and obviously this one will carry the first important mark. You can start from here if you wish. You can start from either of the equations here on top. Okay, so from here we are just going to substitute the numerical values we have, and the numerical values are, the mass is 100 kilograms, so it's 100 multiplied by the acceleration due to gravity is 9.8 multiplied by the height is 5 meters, is the initial height, plus half multiplied by 100 multiplied by the initial speed. Remember the trunk fold, it folds here. It means the initial velocity is equal to 0. So initial velocity or speed is 0 to the power 2 is equal to a mass is 100, 9.8, and the final height is on the ground. So there is not height when it's on the ground or at the bottom of the waterfall. Plus half, the mass is 100, multiplied by final speed square. So this is what they want. You're looking for the final speed, which is just here. So do the calculations, and the answer is going to be the following. The answer for this final speed, I'm going to write it here on the left. Final speed is equal to 9.899. Let's write 9.9. It's very approximately to 10 meters per second. Meters per second down, because they say calculate the velocity, and velocity have direction. I hope this is clear. It is not difficult, and it's going to be used many times in other questions. This is the principle of conservation of mechanical energy. Is important for from grade 10 as well as for grade 12. So good luck. Thank you for watching. Thumb up if you think it's helping, and up until the next video. Good luck.